Hello guys, now we're gonna do the Thevenin theorem. Okay, so this is quite a simple theorem. Is one. Let's just read the theorem first. It any two terminal any two terminal network containing resistances and sources of EMF may be replaced by a single source of EMF V Thevenin in series with a single resistance R Thevenin. Okay, so any two-terminal network ifana uba yinto enjengo-single phase, yabo, iline esombane then ibe iline return umbane back to the source because umbane usuka from the source athi go around the circuit athi go back to the source through the second wire. Okay, so we are talking of it any two terminal which is single phase. So according to this theorem, we can take any circuit and kind of reduce it uh, to this equivalent circuit, which we call Thevenin equivalent circuit. Okay, depending on this depends, guys, on which current on which resistor do you want to calculate current flow in. What is our resistor of interest? Okay, the resistor of interest is the one that you are being questioned on. You will see when I do an example. Okay, we see that a Thevenin equivalent circuit consists of a Thevenin EMF in series with a Thevenin resistance. Yeah, okay, let us write that as terminal A, terminal B. Okay, this is every time we are doing in Thevenin's theorem, we are reducing the circuit in this format. Okay, so let us do the first example. Let us do the first example. Okay, let me just draw the circuit quickly. Okay, okay. 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 So okay. Up we're given 20 volts. We are given R1, which is 20 ohms. Then we are given R2, which is 12 ohms. We are given R8, sorry, R3, which is 8 ohm. Okay, then we are given R4, which is 11.2 ohms. The question, it says calculate the current flow through R4 making use of Thevenin. So they want us to calculate a current through R4. Okay, guys, when you do it Thevenin, the question is the one that is guiding you about which which resistor of interest are you dealing with? Of which is a resistor, because they want us to calculate the current flow up through OR4. That means OR4 is our resistor of interest. And the first thing that we do, we're gonna remove or resistor R4, okay, and replace it with an open circuit. That's the first thing you do. Let us remove, okay, sorry, okay, okay. Uh, okay, sorry. Mhm. Okay, we have removed to R4, okay, because it is our resistor of interest, because it's a resistor that they questioned us on. Okay, R1 20 ohms, then R2 12 ohms, then go R3 uh, 8 ohms. Then this is terminal A, okay, this is terminal A and B. Okay, no terminal A and B, guys, ithetha ngayo ngulo okwi-equivalent circuit, kuye lo, these two terminals. So meaning which, guys, if we find ukuthi okay, kubani voltage across this terminal A and B, we have basically found the Thevenin voltage, which is Thevenin voltage yabo nansi. Okay, fine. Okay, how can you find the voltage between terminal A and B? Okay, this is how, guys. We see that uh, the terminal A and B, terminals A and B is connected across this resistor, guys. Terminal A and B is connected across the resistor R3. If we, meaning guys, terminal A and B is in parallel with this resistor, basically. Meaning, if I can find a voltage across R3, I have basically found a voltage across terminal A and B. So let us write that down. Voltage across R3 is equals to a voltage across terminal A and B. And that is in Thevenin voltage. Okay, how do we find voltage between terminal A and B? Okay, okay. What we can do up, okay, let us first look at a voltage source here too as our reference. Nansi voltage source here too, guys. Nansi voltage source here, la 20 ohms. Okay, if siyabona ke ngoku, let me use a different color. Okay, if voltage, le resistor is connected in parallel with this whole combination. Yekele, yekele. Nansi circuit yakho, because apha sine open circuit, current flow, just that kukhona voltage across. Guys, if sayibona circuit yethu, let me draw it yodwa ecaleni. Ime kanje. Okay, this is how a circuit looked like from um, from from this source point of view. Né? Okay, this is the 20 volts. This is R1, R1. This is R2. This is R3. Now we want to find the voltage across R3. Okay, fine. We know that the voltage upper, the voltage here is 20 volts. Anna. Okay, because this is a parallel circuit, if you can see. Anna. And okay, we know the voltage across these two resistors R R2 and R3 is 20 volts. They are in series, ne? They're gonna share that 20 volts, these two. Okay, but Tina, we want the voltage. Tina, we only want the voltage across this resistor. And we know that the total voltage here on this circuit is 20 volt. And they are in series. Okay, but the voltage, that 20 volt, is shared between R2 and R3 because they are in series with each other. Then they are in parallel with this resistor. Okay, but since we know that the voltage in this series combination is 20 volts, we can use the voltage divider rule. We can use the voltage divider rule to actually calculate how much voltage is there across R3. Okay, which is R3 plus R2 times VT. Okay, so what is my R3? My R3 is uh, my R3 is 8 ohms, 8, 8. My R2 is 12 plus 12 and times 20. Okay, the voltage across R3, okay, is equals to 8 volts, which is equals to V Thevenin. Okay, V Thevenin, which is V Thevenin is the voltage across this terminal and this terminal. I have shown you why it is equals to, because Galogo, because this the terminal A and B is connected across this resistor. Hence, if we calculate the voltage across R3, we have basically calculated the voltage across A and B. It's like it's like terminal A and B. It's when you put your meter. Let's say you put your multimeter to measure the voltage across here, and when you're measuring a voltage across a resistor, you connect it in parallel with the resistor. These two, the terminal A and B, are connected in parallel with that resistor. Hence, that is why we're calculating OVR3 to find the Thevenin voltage. Now that we have found the Thevenin voltage, we have to find now the Thevenin resistance, guys. You have to find the Thevenin resistance. When you are finding the Thevenin resistance, you have to find the Thevenin resistance, and because we say we simplify a circuit here to a Thevenin voltage in series with a Thevenin resistance. When you are calculating the Thevenin resistance, what you do, you short circuit the voltage source. Okay, the next thing, we short circuit the voltage source. Okay, let us do that. Let me use a different color. Let me use pink. Okay. Sorry. Okay. I'm short circuiting the voltage source here. So, okay. Guys, there's something I'm gonna show you in this. There's something new that you're gonna learn in this calculation that I'm gonna show you. Okay, this is our R2. This is our R1 still, nah? We haven't changed anything, guys. We only short-circuited the voltage source. Okay, we just short-circuited the voltage source. Guys, I have a question here with regards to this. Guys, look at here. All resistor R1 is connected in parallel with the short. What does that mean? Guys, if you connect a resistor in parallel with a short circuit, and let's say you connected a 20 ohm resistor in parallel with a short. What is the resistance of a short circuit? It is 0. What is the total resistance? The total resistance when you connect a resistor in parallel with a short, let's calculate it. 0 times 20. 20 plus 0. The total resistance will always be 0 ohms, guys. The total resistance will always be 0 ohm. So, guys, we can treat this combination as 0 ohm, this one, because this resistor is connected in parallel with a short. Yeah, so we can treat it as if this circuit now because this resistor is connected, because this resistor is connected in parallel with a short. The overall resistance in this section is what? 0. So we can treat this circuit as if it is like this now. Okay, that is logic. That is logic. If you connect even if this resistor was 1 billion trillion mega ohms, oxalayo, if you connect it with a short, the total resistance is 0. That is a fact. Okay, so it's like now our circuit is like this: R2, okay, uh, R3, okay, then terminals A, terminal B. Okay, now we have to calculate the Thevenin resistance. Thevenin resistance meaning the resistance between terminal A and B, which is the total resistance. We can see that R2 and R3 are in parallel. So R Thevenin is equals to R2 times R3 over R2 plus R3, where R2 is 12 times 8, then, okay, 12 plus 8, product over sum rule, which give us a Thevenin resistance of 4,8 ohm. Guys, now we have calculated the Thevenin voltage. We have calculated the Thevenin resistance. Okay, now we just draw a Thevenin equivalent circuit. Every time you do a Thevenin theorem, you will always end up in this situation. You will always end up with a Thevenin equivalent circuit. Okay, sorry. Okay. Okay. Terminals A, B. Thevenin voltage was 8 volt. Then Thevenin resistance was 4,8 ohm. Okay, the question wanted us to calculate. Now, wanted us to calculate the current through the R4, the R4 resistor. The resistor that we took out, né, we can now take it and put it back into the Thevenin equivalent circuit. Né? Okay, which is R4 is equals to 11,2 ohms. So what are you doing when you're doing Thevenin theorem? You look at the resistance of the resistor of interest. You take it out of your circuit. You replace it with an open circuit. Then label terminal A and B. Then you calculate the Thevenin voltage. After calculating the Thevenin voltage, you short circuit the voltage source so that you can be able to calculate the Thevenin resistance. Okay. Now they want us to calculate the current. We have the voltage. We have the Thevenin resistance. Sorry, let me use a. We have a Thevenin resistance in series with this R4 resistor. What does that mean in terms of current? It means that, sorry, it means that if I can calculate the current, the source, the current that is flowing here is the same as the current that is flowing here. This is a series circuit. So IR4 is basically the total current in the Thevenin equivalent resistance, which is V Thevenin over R Thevenin plus R4, which is 4,8 plus 11,2. Okay, that is 0,5 amps. Okay, guys, I chose this circuit. If I chose this question because we have two sources and they want us to apply Thevenin. And okay, the first section of the question, they wanted us to calculate the unknown resistor, of which is when it is calculated, Puma no 7,556. Then the follow-up question says use Thevenin and calculate the current flowing through the 10 ohm. Okay, and if we see that in this circuit we have two sources as compared to the previous previous question that I did, which was from an example where we had only one source. Up we have two sources. When it is two sources, guys, when we are calculating Thevenin resistance, when you are calculating Thevenin's Thevenin's voltage, you're gonna see that we sort of like now we are applying a now we are applying a superposition because we deal with each source acting separately. Okay, so Determines when you are going to use Thevenin's theorem, you first look at the resistor of interest. This is the 10 ohm resistor. So this is our resistor of interest. That means we're gonna have to take out that resistor from the circuit and replace it with an open circuit. Let us do that. Okay. Sorry. Okay. Okay, sorry. Um, this is R1. Yeah. This is R3. Okay, guys. Okay. Uh, okay. Now we're gonna remove this resistor with an open circuit. Terminal A, terminal B. Okay, this is V1, this is V2. Okay, what's different about having multiple sources, two sources, ne? What is different is that uh, when we finding Thevenin voltage, we first consider each source acting separate. That means we short circuit one source and see about okay, it's Thevenin voltage engakanani. Then we bring back the one that we short circuited and short circuit the other source. Sibone uba isinika Thevenin voltage engakanani. Yabo, those two Thevenin voltages sizozifumana ke ngoku. We're gonna calculate the difference. Okay, we're gonna calculate the difference. So, for example, let's say I want to determine how much voltage uh, is this source uh, contributing to this terminal A and B. So that means I'm gonna short circuit this source. So let us write down short circuit, sorry, short circuit, sorry, short circuit V2. Okay, now let us draw our circuit. Okay, okay. Okay, we have short circuited this source. Okay, okay. Then Okay, V1. Okay, that was R1, R3. If we can see now from this circuit, we see that uh, the voltage across terminal A and B is equals to the voltage across R3. How so? We see that, let me use a yellow color. This terminal A and B is connected across this resistor. Yabo? Yabo? One side is connected to this one side of the resistor. The other side is connected to the other side of this resistor. Yabo, it's basically connected in parallel. And it's basically connected in parallel with that resistor. Hence, if I want to find the voltage between terminal A and B, I have to find the voltage across resistor R3. I hope you guys get me. Yeah, well, we cannot say it is connected between, let me use a different color, between we cannot say that terminal A and B is connected across a resistor R1. Yeah, why? Because, okay, fine, this terminal A is connected to one side of resistor R1, but with terminal B, there is a battery, there is another component, there is the source, yeah, which is which means that it is not actually connected across, because if it was connected across or resistor R1, then terminal B would be like this. Then we can say it is across or resistor R1. No, guys, that is not true. The one that is connected, uh, the the one that terminal A and B is connected across is resistor R3. Ngiyabona na? Okay. Now let us find the voltage across R3. If we can see that, let me use a green color. This, guys, is a series circuit. Okay, this is a series circuit. So, meaning which, if I can find, meaning which I can use a voltage divider rule. VR3, it's R3, R3 plus R1 times V1. V1 must move VT weight. It is our total voltage. Then it's equals to R3 besithe ngubani? R3 wethu besithe ngu 7,556 7,556 plus R1 ngu 8 ohms. Then V1 it's V1 it's 21 ohms. Okay. Let me just punch the calculator. Sorry. 7,556 over 7,556 plus 8 times 21. That is gonna be OVR3. Okay, it's equals to 10,2. Let's say 10,2 volts. Okay, this is equals to Thevenin voltage due to V1. Okay, then the next thing we're gonna find Thevenin voltage due to V2. meaning which, guys, we're gonna short circuit V1 now. Yeah, but because we want to find a contribution V2 to this terminal voltage A and B. Because the terminal voltage A and B, Thevenin voltage. Let me use the blue color and draw the circuit. Okay. 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 Sorry. Oh, sorry, we are short circuiting this one. Sorry. My bad. We said we are short circuiting V1. Okay. Sorry. Okay. Okay. There we go. Okay. Okay. This is R1. This is R3. Okay, this is terminal A, B. Okay, guys. Now we want to find a voltage, a Thevenin voltage due to OV2. Okay, we see that terminal A and B is connected. Guess it. There is connected across or resistor R bani R1. Okay, that means if we can find a voltage across R1, we basically found a terminal voltage between A and B. Okay, we can see that, okay, apha sine series circuit ne zisherisha i-voltage engubani engu-V2, u-V2 ngu-30 ohms. This resistor and this resistor are sharing 30 ohms. We're gonna use a voltage divider rule to find OVR1. Okay, because OVR1 is equals to a terminal voltage between A and B. That is a terminal voltage, the Thevenin voltage due to V2. Okay. Okay. So I'm gonna say VR1 is equals to R1 over R1 plus R3 times V2, which is R1 is 8 over 8 plus R3 is 7,556 times 30. Okay, R1 is therefore equals to, let's punch that. Okay, 8 over 8 plus 7,556 times 30, which is 15,428 volts. Now that we have found a Thevenin voltage due to OV2, we have basically found a Thevenin voltage due to both sources. Okay, because this is a multiple source circuit. We have found a Thevenin voltage due to OV2 and due to V1. What we have to do to find the resultant Thevenin voltage, we only calculate the difference. About the difference, you take the bigger value and subtract you subtract the small value from the bigger value, which is 15,428 minus 10,2. I-resultant Thevenin voltage kubani? Let's calculate. Okay, 15,428 minus 10,2. That is gonna be 5,228. 228. Now, okay, we have found a Thevenin voltage, guys. Okay, we have found Thevenin voltage. After finding a Thevenin voltage, we have to calculate a Thevenin resistance. To calculate the Thevenin resistance, we short circuit all the voltage sources. And we short circuit all the voltage sources. Yeah, short circuiting OV1, and I'm also short circuiting OV2. Okay, if siyabona ke ngoku, if sizobala resistance between terminal A and B, and you can sort of like, we're treating at terminal A and B if source yakho, you would see that, okay, uh, you would see that, okay, R3 no R bani no R1 banjani ba in parallel. Yeah, because if it's not okay, terminal A and B source yethu, a current ithini iyasplita, isplite buyele ngapha iphinde idibane apha buyele ngapha. We can say R1 no R3 are in parallel. So that means Thevenin resistance is equals to R1 times R3, R1 plus R2. Okay. Okay. So that is gonna be R1 go 8, is times 7,556 plus 7,556. Therefore, Thevenin resistance is, let me check my calculator. 9,556 over 8 plus 7,556. That is gonna be 3,886 ohms. Okay, now we have a Thevenin voltage, we have a Thevenin resistance. We can basically draw a Thevenin equivalent circuit. Okay. Okay. Yeah, doesn't matter a circuit binjani. When you're doing a Thevenin theorem, you always end up. Okay. A and P. And the Thevenin voltage is 10 go 5,228 volts. Then the Thevenin resistance 10 go 3,886 ohms. And then now we can put back our resistor of interest, and which is that 10 ohm resistor, and we're putting it back the one that we took out, we put it back, and yabona guys, when you're doing thevenin theorem, you always end up with a circuit that is a series circuit, and you can easily calculate now the current, because the current eflowa kule resistor ifana noba yi-total current yale circuit, so which is I let's say current through the 10 ohm resistor is equals to V thevenin over R thevenin. You always end up with this formula plus R 10 ohms, which is I need space, sorry, which is 5,228 over 3,886 plus 10. Therefore, the current money. Okay, let us punch our calculator. 5,288 over 3,886. Sorry. Over 3, plus 10. Okay, that is gonna give us 0.37 which is amps or in milliamps izoba ngu 376,494 milliamps. Okay, guys, that's it for this series here. Superposition Thevenin theorem. Guys, ndiyanicela, please like my channel and subscribe to my channel. Invite nabantu abangayaziyo this channel, because it's a productive channel for TVET college students, yabo, so that I can try nam and essential nam ndibe encouraged the produce more content, more subject, and cover more subject to help you guys reach to because what I'm doing here, I'm also helping you guys reach your full potential. Yabo. Thank you guys. Enkosi kakhulu. May God bless you.